Hi, hello friends, welcome to Sandeep'S. In today's class, we are on part 3 of acid, bases and salts. In this video, I am going to discuss about bases, what are its classification, what are its uses and its chemical properties too. And without wasting time, let's move on to the video fast. Now let's talk about some introductory part of bases. First thing, bases are basically bitter in taste. Bases are bitter in taste. When you touch the base, how do you feel? You feel it is soapy in nature. And when you dip blue litmus paper into a base, what will happen? When you dip blue litmus paper in a base, what will happen? There will be no change. There will be no change. But in case of a red litmus paper, what will happen? It will change into blue litmus paper. Okay, so when I add base into water, what will happen? So it will produce hydroxyl ions. This is called hydroxyl ions in aqueous solution. Okay, first it is bitter in taste, then soapy in nature, then blue litmus, it has no change, red litmus to blue litmus, then it produces hydroxyl ions in presence of an aqueous solution. So now let's see about the classification of bases. So classification of bases are of two types. First, it is based on the strength of the bases. Second thing is based on the acidity. Acidity of bases. First, let's talk about based on strengths. Based on strengths, there are two types. One is strong base and one is weak base. Strong base are those which completely ionize in aqueous solution to furnish high concentration of OH minus ions, that is hydroxyl ions. Okay, so they completely ionize the base by OH minus ions. So for example, NaOH, KOH. So like if you take NaOH, when you add water, what will happen? It will dissociate as Na plus OH minus. This is how we explain the strong base. Next, it is weak base. Weak base are those base which partially ionize in aqueous solution to furnish low concentration of OH minus ions. Okay, so for example, NH for ammonium hydroxide, calcium hydroxide. So these are those which partially ionize. So next is based on acidity. Acidity is nothing but number of replaceable OH minus ions in a base. Okay, number of replaceable OH minus ions, that is acidity of a base. It is divided into monoacidic base and it's divided into diacidic base. Mono means it is 1, di means it's 2. Okay, monoacidic examples are NaOH, KOH, NH4OH, etc. So many more are there. Diacidic base, for example, calcium hydroxide and magnesium hydroxide and many more. So now let's see about the chemical properties of bases. First, reaction with metal. So any metal, let's take zinc plus any base, sodium hydroxide. zinc plus sodium hydroxide will give me sodium zincate, will produce me sodium zincate plus H2 gas liberation. Next, reaction with non-metal oxides. Non-metal oxides, it's nothing but carbon dioxide. Any base you can take. Let's take NaOH, and it will produce sodium carbonate plus remaining, it's nothing but your water. Okay, next, reaction with acids. So bases reacting with acids or acid reacting with bases, both are same. They are called as neutralization reaction. They will give us nothing but salt. So any acid, that is HCl, plus any base, let's take NaOH, will give me, that is nothing but your neutralization reaction. NaCl, which is a salt, NaCl plus remaining is nothing but salt plus, that is water. So next is reaction with heavy metal salts. So let's take zinc sulfate, that is reacting with sodium hydroxide. That will give me sodium sulfate plus zinc hydroxide. Zinc hydroxide. Next, reaction with water. So NaOH, that is reacting with water. What will I get? It is Na plus COH minus. That is, NaOH is dissociated into ion. So now let's see some uses of bases. First is potassium hydroxide, KOH. It is used in alkaline batteries and soft soaps. And next is calcium hydroxide, CaOH twice, that is manufacturing of bleaching powder, softening of hard water. Then ammonium hydroxide, NH4OH, that is used for removing grease stains from your cloths. Let's meet on the next video. Until then, bye.